rendered properly in 12-tone equal temperament. So I chose to break the chain from measures 8 to measure 9 because in 22-tone equal temperament, the E flat up and the A flat up 7 chord only goes up 1 degree to get to an E flat minor chord. So it seemed like a logical place to change something such that the last part of the progression was a semitone flat of where it normally was. It would be interesting if someone created a progression where you start at measure 5 of this on the F major 7 and just keep going down by semitone when it goes down by 1/22 of an octave. That's kind of what I was referring to subjectively earlier. So anyway, hopefully that piece is kind of interesting. It doesn't exhibit structural drift, but we got the 12-tone progression to drift down a semitone and thus have the same tonic as before. So structural drift same tonic or structural drift different tonic. These are fluid concepts. So our next song is Catalysis by Zappa. This is a song in 22-tone equal temperament from Microbiological. It's very groovy. It has kind of like a groovy sandwich going on. The first part is groovy, and the middle part is a little modulatory, and then there's a groovy part at the end, and that tends to be something that I think Zappa does in a lot of his songs. It's a very cool formal technique. So, when I heard this song, there was a middle section where I suspected there might be 2 different D dominant chords, and so I only analyzed this middle section to see if there was any Zenharmonic structural drift. The answer is kind of surprising. I created a tonic interpretation in 12/10 and an adjacent interpretation in 12/10 using melody and chord roots again. So, realistically, we would get 4 different interpretations, right? But this progression not only does not exhibit Zenharmonic drift, but all of the interpretations agree, which means that I only need to write a version in 12/10 once, because either way we'll get the same thing. So, if I'm starting from the tonic and comparing the melody from there, I get the same thing as doing it as I go, and then the same is also true if I apply that to the chords. It's even true if I apply it to the descending chromatic scale in the bass: G, F sharp down, F, E down, E flat, D. So this really does not exhibit Zenharmonic structural drift, and you could say that the interpretations don't disagree with each other, I suppose. So it's quite clear how one is supposed to play this in 12-tone equal temperament if you were to analogize it. But the qualities are simply so different, and some of the chords hit in spots that are so out of slot that it still does sound Zenharmonic. So here's how the original song goes. We'll kind of lead into it, and then you'll hear that interlude in just a sec. Right there. Yeah, so there we go. That's the interlude section. Now here's what it sounds like in MIDI. Play the version in 12-tone equal temperament, where all the interpretations agree. It's strange, isn't it, how those match up? There's several little wonky intervals that are different in 22/10, but they all smooth out in 12/10. The biggest unexpected finding from this, I think, was learning how to spell. It's kind of expected that these don't exhibit as much structural drift as I might have thought because of what I mentioned earlier about how various pairs of 22/10 intervals that are right next to each other that where one seems like, more Zenharmonic than the other, they'll just analogize or approximate to the same 12/10 interval. And so a lot of stuff, I think, gets smoothed out easily if you're not consciously trying to write in a way that exhibits Zenharmonic drift. When it comes to spelling, the lesson was that when I tried to render things in 12-tone equal temperament with various different interpretations, that also taught me the best way to spell what I was going for. And when I tried to write it in 22 tone equal temperament initially, I would spell it in a way that was slightly more inconvenient. So I think this sort of analysis could be a good tool for finding out the good spelling of a chord if you're having a question about it. So when analyzing entrance, there is this chord that I would spell as sort of a B flat down chord, which can be spelled as an A chord. I spelled it as B flat down because we were in flatty territory and because the seconds in there line up nicely if I do it that way. But really, if you're playing it in 12 tone equal temperament, you'd want to see A instead, because otherwise you'd have to think about B double flat. So it all depends on the tuning system you're comparing it to. I also initially spelled that secondary D chord that I noticed that I thought made its enharmonic as D up, because I thought it sounded like D, but you really should just spell it as E flat. There's no reason not to, logistically. So let me go ahead and compare how these look on the page for you. So here's entrance. You can see that at the top, at measure 7, and measure 8, we've written things with B flat down, major 9 chord with an F down in the bass, so that's just telling us that the 5th is in the bottom, and then the next chord is an A flat up 7 chord. So, that's a lot harder to spell in 12/10 if you keep it in that flatty realm. But if you move to the bottom, you'll see that at measures 7 and 8, we've spelled it as A major 9 and G sharp down 7. So, A is easy to spell in 12 tone equal temperament, so that's a good reason to have that. And if we move to G sharp down, it kind of keeps the melody intact for that small portion, and then it also breaks the chain. And what I mean by that is, you can see that the A flat up 7 chord at bar 8 and the top line, it goes to E flat minor. Well, E flat up goes down to E flat. So this shift by a degree of 22 isn't really all that well represented if you have flats going on. But if you have sharps going to flats, that kind of represents more of a jarring key change visually on the page. Unfortunately, the biggest drawback of that, the bottom line that is that if you go from G sharp down 7 to E flat, it means that the melody's second kind of gets lost and it looks like a third instead, which is less desirable than the A flat up 7. So pros and cons. The pro of writing it in the flatty way is you get some melodic stuff working out and you stay flatty, and the pro of writing it with A is it's more like it would be in 12 tone equal temperament and you visually break a chain. Then this other one here, E flat gives us more of its role in the key and preserves the spelling of melody notes in G. Otherwise you can see if I write bar 5 as a D up chord, I have to put in C sharp up and C natural, whereas it's much easier to just pretend like things are in various modalities of G. Our next song will be Gleam by Sevish. This is one of the more famous pop songs in 22 tone equal temperament. I've played a cover of it as well, so I know the chords. It's from his album Harmony Hacker, which features a lot of creative 22 tone usage. I really want to say a big thank you to Lumi Music and Theory, the YouTube channel. Lumi's done some great stuff, and I really appreciate the transcription they put out because it allowed me to check my work and mostly confirmed, certain suspicions I had or didn't have. So with Gleam, I created a tonic interpretation, and an adjacent interpretation, but I only did it by comparing the roots. I didn't go through and just do a melody, which I thought was okay, just because there are so many different melodic notes that it would probably result in interpretations that I couldn't justify as easily. And Gleam's interlude is also longer. We're only examining the interlude today. We're not examining the main part, although I'll play the main part for you so that you recognize it, and then we'll move into the interlude. The interlude contains some interesting shifts. There's a way we can break the chain by going back to stuff, and there are ways that neutral seconds versus major seconds kind of disrupt it. So anyway, this progression does exhibit Zenharmonic drift, and you can add drift by an additional semitone if, when you repeat, you choose to, in the adjacent interpretation, keep the correct relationship between the last chord of the first ending and the next chord to restart, because then it will drop by a semitone. So I'll show you how that sounds and looks, an adjacent interpretation, including that repeat, would drift down a whole step compared to the tonic interpretation. Pieces of the progression sound significantly shifted. So let's take a listen first to Gleam, sort of with part of the hook here, and then we will continue onwards when the interlude starts. I'll tell you when it starts. Here's the interlude. So that's how that section goes. There's lots of interesting things about it, especially the last chord being an add 11 chord, but it's constructed from fifths such that you get the up fourth for the 11th partial, even though it's just C down to F sharp. The F sharp is being constructed from the other fifths, from the minor third and then the seventh. So that's pretty neat. There's C sharp down a lot. That's a really important relationship to A, having chords that are a major third away from it. So I think it's quite fair to assume that A is the tonic in this. So let's check out the adjacent interpretation. The adjacent interpretation, of course, will always drift more compared to the tonic version, since the tonic version is always just anchored around the tonic, but the adjacent version is free to move around. So let's take a listen. So you can see that that progression ends on C, which is a semitone lower than the tonic interpretation we'll end up on. With a C sharp, we traditionally think of it as a major third. At the first repeat, you'll notice that last chord was also a C sharp instead of a D. So it doesn't have that same relationship. Here's the tonic chord version. You might notice that in this progression there was more of a raise. You see here at bar 7, it goes up to a B flat chord instead of an A chord. That's because in the 22 tet version, bar 5 is A, bar 6 is G up, and then bar 7 is A up. So it's shifted up 1/22 of an octave. So in this version, we have to preserve that shift, but in the adjacent version, that shift goes away because both the 22 tet 4 degree step, like the major second, and the 3 degree step, the neutral second, both of them would just nullify to a major second in 12th unequal temperament. So it just goes back and forth and gets rid of that nuance. So here's kind of my best fit version. This is a version that I think works the best and does not have any drift and ends up on C sharp. It still lets you shift up at bar 7 so you can hear that brightness, but it also gets rid of some of the other trappings. So there were a few compromises, such as when we went up to the B flat chord in bar 7, we have to make the bass go down a minor second to reach that chord instead of what we would like from 22 tone equal temperament, but them's the breaks. So I have one more version of Gleam for you, and in this one I used mostly adjacent logic, and I purposely tried to make it drift as much as I can, so that ends up being a major second lower than it is supposed to be, assuming major thirds are the same between tunings. So you'll be able to see that when we get to the C sharp chord at the end of the first ending, instead of it going back to A, it will correctly utilize a fourth relationship and go to A flat or G sharp, and then it will have gone down a minor second at the repeat, and then we can use the adjacent interpretation to continually go lower. So here's how that sounds. So there you have it, some interpretations of Gleam and how it can be different in 12/10. What's really interesting about this is Sevesh himself will render his songs in 12-tone equal temperament to demonstrate how colorful and iconic microtonal intervals are. And he did this with Gleam, actually. And the way he wrote it out in the YouTube video was that he mapped every 22-tone note to its nearest equivalent in 12-tone equal temperament, but not just roots or melody notes. Like, he went through the entire interval list, and then whichever one was closest, he consolidated them, similarly to how we mentioned earlier. The qualities of certain chords change greatly as a result of this. Here's sort of the lead sheet that I figured out. If you want, you can listen to the video yourself. Our last song that we'll be looking at is We Can't Be Blamed, which is also by Sevesh. And it's from Harmony Hacker. The main chord progression is shorter and more repetitive than Gleam, but it's also highly chromatic. Let's see, the chord progression is the second construct you hear in the track, and I'll play it for you. I created a tonic interpretation in 12-tone equal temperament, as well as an adjacent interpretation, both using melody and chord roots. This sequence is really short, not very melodic, and you could say the notes are derived from the chords, as each of them have the qualities of major sevenths. Some have wolf fourths or fifths mitigated by internal relationships, as is characteristic of 22/10. We also saw this in the Brendan Burns song. This progression exhibits Zen harmonic drift by breaking in the middle of the progression when a neutral second is used in the roots. It would be an interesting choice for an adjacent interpretation where the up fourth counted as a 12/10 tritone instead of a 12/10 perfect fourth. A tonic interpretation of the roots drifts up a half step compared to the adjacent interpretation, G flat versus F. So let me play through these for you. Here's the original version with the build-up. So you can hear the chord progression there. Here's the MIDI version. Some of these move by tritones and they interestingly don't add up. Here's the adjacent interpretation. Sounds pretty similar. Here's the tonic chord interpretation. We had the adjacent chord interpretation just now. You'll notice that there's a B flat major 7 in bar 2 instead. Here is the tonic melody interpretation. We have a G flat major 7 at the end now. Now, here's something else I wanted to do with this one, now that I've exhausted the interpretations. Oh, the reason we consolidated the adjacent interpretations on that one, by the way, is because the adjacent melody interpretation and the adjacent chord interpretation are the same. So we just consolidated them into one thing, similarly to the Zagla song. So for this last one, I wanted to give all of the chords unique roots in 12-tone equal temperament, because there's these microtonal shadings that are lost when you translate it to 12. And you have two of the same chord in 12, but they're really like 1/22 of an octave away in 22. So this is my attempt to do that by using a C major 7 in the last bar. Take a listen, they're all unique. So anyway, those all have a different spin on them, and I think they're fairly interesting. Well, thanks so much. Those are the 4 songs that I transcribed in 22-tone equal temperament and converted into 12 for the sake of interpretation. I'd like to thank you for inviting me to this conference, and feel free to ask any questions you might have. Thanks.
Let's collect some immediate short question, but of course maybe Joe or Juhani or me, we try maybe to answer it if we can. Gerhard.
Sorry, I keep my voice. It was interesting to hear that the original versions of the songs and then the MIDI versions were a bit different, because if it's worked out as a real song, then there may be also effects by the electric guitar and distortions and such things.
Yeah.
So there, I think this is a kind of timbre thing that the chords still sound different in the composed version or in the pure MIDI chord progression.
Yeah, of course. The timbres are much more musically fancy with the reverb, whatever, and then there's drum sections or rhythmic sections or something like that. But of course, for me, it was so this MIDI version made it clear what is going on harmonically. It is just an analyzing tool in for this type of music, and can I even imagine that it will help if you analyze pop music in 12 equals, so then make just some piano or whatever clear. In case if you have pop music with complex harmonic structures, what could be explained so in this way.
Also, Sevish's music is made with MIDI, so I assume he starts with the more basic sound, because he and then makes it more interesting.
Yeah,
so because because he actually he works on a piano roll
Yeah.
and tries out harmonies on a DAW,
Yeah.
DAW.
So that we that those Stephen Weigel did the process reverse and
Yes.
for us.
I have a question. I mean, it's a shame Stephen's not here, but like I'm trying to understand how this kind of analysis, like what do you do with it? Like why would you do an analysis of a microtonal piece in 12 tone?
Why we do analysis
Of-
generally of
No,
music?
no, of a microtonal piece. What's the purpose of taking it into 12 tone?
This is the
in that
question.
analytical tool, and this is not something he explained, so I was just curious as to like.
Yeah, I think I don't remember anymore what were the answers. I think we have discussed that 2 years ago because Stephen has, I think, 2 years ago made a similar. So this, but then he was, of course, I think there was other questions. It was more melodically approach how to transcribe from one EDO to another EDO. Of course, then I think if I remember right, then he was even from one microtonal EDO to another. But there was one little snippet what he said, why Savage did it by himself for to demonstrate how much more interesting is the microtonal version. So that is
Yeah, so it's like a pedagogy.
Well, his
I mean, I